Hello everyone, welcome to today's video. So today we are solving the majority element problem in LeetCode. It is one of the problem from top interview 150 questions list. And we are given an array nums of size n and we have to return the majority element. So definition of majority element is the number which has appeared more than n divided by 2 times. So n divided by 2 times means if, for example, in this array we have 3 elements. If we divide 3 by 2, then it would be 1. So we have to find element which has appeared more than 1 time, which is 3. Okay, so in the next example we have 7 elements. If we divide 7 by 2, it would be 3. So we have to find an element which has appeared more than 3 times, so it's 2. Okay, so that way we have to find the number, majority element. So we have two ways to solve this problem. The first one is we count the frequency of each element and we store it in a hash map. So in hash map, the key would be number and the value would be its frequency. So for each element, we will be counting the frequency, and once we have counted the frequency, we just iterate the hash map and we find the majority element. But that would be space inefficient because we have to store each element and its frequency in a separate data structure. Instead, we have a better algorithm, which is Moore's voting algorithm. So the algorithm, I have already solved this problem using that algorithm. So algorithm works like, we have to uh, maintain a result. Okay, so the result is nothing but the index at which the result would exist, and we have to maintain the count. Okay, so these two variables we have to maintain, and we have to iterate the array, and based upon this condition we will be able to find the result. Okay, so let's go through this algorithm. So our count is 1, so we assume we have counted the first element, so result it's initialized to this index. So let's take this example. It is initialized to this index 2. Okay, so as we have already counted this element, so we have already initialized count to 1. So we are starting the array from the next index, okay, first index, and we're iterating through each element. Okay, so we have to check two conditions. So first condition is if num of I is equal to num of result. So if the element at current index is equal to element at the result index, then we have to increment the count. That means we have found a similar element, we have to increment the count, like we have to vote for it again, and we have to increment the count. If the number at result index is not equal to the number at current index, we have to decrement the count. That is the first condition that we have to check. And if at any point in time, if our count becomes 0, then we have to reinitialize our result index. Okay, so that we will see why we have to do. And we have to go back to first condition. The first condition is our count will be again 1 and we will have new result. Okay, so if at any point if count becomes 0, we are initializing current index as a new result. So we are assuming that the previous result didn't work out, so we are assuming the current index as a new result and initializing count back to 1. And this we are doing for each iteration. This condition we are checking at each iteration, and we are just returning the number at result index. Okay, so let's take this example. So now result is at 0 and our I is at first index. They both match. So let's open Notepad and keep a track of it, otherwise we will lose the track. Okay, so I is equal to 2 and I is equal to 1, and our result is at 0, and our count is at 1. Okay, when we move to the next counter, we are already at 1. Okay, we check array of like nums of I, which is 2, and nums of result, which is 2. So we increment the count is now 2. Okay, next index is 2. Okay, and as count is not equal to 0, we don't have to reinitialize our result and count. Okay, so next index is 2, which is here. Okay, and the element at 2 is 1. Okay, so element as 2 is 1. So let's write that as well. Nums of I is equal to 1. Okay, so nums of result result is still at 0. So 2 and 1, they don't match. So we have to decrement the count, and count is still not equal to 0. So this won't execute. Okay. Now result is still at 0. So next index is 3. Our nums of I will become, it's still 1 because next element is again 1. Okay. Then again we check the condition. Nums of result is 2, nums of I is 1. They don't match. Now our count again will, this else condition will evaluate. Again it will become 0. Okay. So now this condition will become true. So as per the algorithm, now the count has become 0. So we have to find the new result. Okay. So the new result would be current index. The current index is 3. So we reinitialize it to 3, and we, as we have counted that element, we have to reinitialize count to 1. Okay. We move to next index, which is 4. At 4, we still have 1, right? At 4, we still have 1. Then 1 and 1, they do match. Okay. So we have to increment the count. It becomes 2. And this count is not equal to 0. So this won't evaluate. We go to 5. 5, we have 2. Okay. So nums of result is 1, because at 3 index we have 1, and at nums of 5 we have 2. So they don't match. We have to decrement the count. And again, count is 1. So this condition won't evaluate. At nums of 6, again we have 2. Again, result is at 3, which is 1. So the nums would be 1. So nums of I is 1. Nums of I is 2, and nums of result is 1. They don't match. We have to decrement the counter. So the count is 0. So this condition will evaluate it true. So now result will be the current index. We have to find a new result. So the new result is at current index, which is 6. Okay. So number at 6 is 2. So that would be 2. Okay. And we have finished to the elements. So the result would be a number at element at index 6, and that is 2. Okay. So that is how this algorithm works out, which is the correct answer. So and it is this algorithm works out well, because if we have element which appears more than half of the size of array, then there would be a number which would be next to each other, or at the end of the array, or in the middle, and eventually the count, the resultant will stop at the element which has appeared more than the half of the size of array. Okay. So it's pretty simple algorithm, but it works well. Okay. And we have solved this problem in a linear time, so that is more important, and we have consumed only O of 1 space. Okay. So let me know in the description if you want me to explain this problem in a more simple way. I tried my best using Notepad. I guess if I write down the problem in like a Paint or in any other tool, that would help. But yeah, if you don't understand it, let me know in the comment section. I would try to explain it in a more simple way. So let's meet in the next video, where we will be solving the next problem from this top interview 150 questions list. Okay. Thank you for watching this video. Please do like and subscribe this channel, and I would see you guys in the next video. Bye.